our EEE 312 project, voice-based wheelchair control. Wheelchair is one of the most essential equipment for the physically disabled people. As it is a passive device, it always needs a person as a muscle to control its movement. So what if we convert the wheelchair itself as a muscle and modify the requirement for the person behind it? On the other hand, despite of being one of the most widely spoken language in the world, no significant effort has been made in Bangla speech recognition. Keeping all these things in our mind, we have designed a prototype of wheelchair which will take Bangla voice command from the user and operate it by itself. We have implemented two different models for our wheelchair. One is for personal use and it will only operate by the voice command of a specific person. And for other model, that is for general use and it can operate by anyone's voice command. This is the detailed flowchart for the first model. At first, we have built a database collecting samples from our friends and family. Our database contains around 1500 .web audio files of people saying 5 different Bangla words, which are Shamne, Pichone, Dane, Bame, and Thamo. For feature extraction from those words, we have used MFCC. KNN is used for detection. Then the command is sent to Arduino Uno and it controls a motor by the command it has received.
The conversion matrix obtained was for KNN. We have used KNN for classification and MFCC for feature extraction. We have collected around 300 voice data from our classmates and some external users. We have used that data in order to access the partner model. It performs well for trained data, but if we use some external data, its performance is not that good. But as we know, we use wheelchairs for very critical cases. We can't really allow that much inaccuracy. That's why we have tried to get a better model, and C1 and CNN was a better model to give very high accuracy. In our CNN model, we have used 25 layers for improving the partner squad model. We have added noise to our main data set and got almost 12,000 samples in our augmented data set. We have created six output classes. Of those output classes, 5 was our commands: Shamne, Pechone, Dane, Bame, and Thamo. We have also used an unknown class. Voice commands that are not included into those 5 commands will be classified as unknown. The training progress graph shows the accuracy of CNN model. It shows that the model accuracy is around 92.1%. In order to show the individual accuracy of those commands, we have shown conversion metrics. For BAME, the accuracy was around 82%, but for all other commands, the accuracy was more than 95%.
For the hardware implementation of our project, we will need to install some motors to our wheelchair, and then we will need to run the motors using a battery. And we will take the audio input using a microphone, and that audio input will be processed by a processor or microcontroller unit so that it can detect the command, and it can the microprocessor unit can run the motor driver so that it can run the motors accordingly. So for our initial prototype, we have implemented this by using an Arduino Uno L29810 motor driver and 2 DC motors and a 12-volt LiPo battery to achieve this. And if we wanted to achieve this in real time, then we will need to install the motors to a wheelchair using chains and sprockets and gears, and then we will need a bigger battery and a bigger motor driver, specifically motor driver BPS7960 to achieve this. So this is the cost analysis for our project. For our initial prototype, we have used Arduino Uno L298 motor driver, battery, robotic chassis, DC motor and wheelchairs, and the overall cost of our project is 4,000 taka. We have already implemented this prototype and we will demonstrate this later in our class. And we have also computed the cost for a real size wheelchair, and the cost will be around 35,000 taka. And we have seen that according to market analysis, the available products that are available in the market right now, those price ranges from around 80,000 taka. So our prototype will be a very feasible solution. in order to achieve this.
Now, what was the inspiration behind our project and what is the implementation of it? So, while we were looking for project ideas, a post in CSB caught our attention. A student who was suffering from leg injury was looking for a wheelchair. So, a thought occurred into our mind that even if he manages the wheelchair, still all the time he has to depend on his classmates or friends for his mobility. Although this is for a short time until he recovers. But what about the students who are disabled by birth? So that's when we decided that the goal of our project will be ensure an environment-friendly campus for the disabled people. So first we will provide wheelchairs to Kuwait Medical, which will be only used for Kuwait students, teachers and staffs. If this becomes successful, we will gradually supply this wheelchair in local hospitals, which will be used for all general people. Even elderly people and people with disabilities can also buy these wheelchairs themselves. And moreover, as our project is voice command based, so our code can be used in many purposes like classroom automation, cafeteria digitalization and many other causes which will help us to fulfill our goal to make Kuwait a true technology based digital campus which it is supposed to be. That's all. That's the team behind this project, ID 21, 23, 24 and 26. Thank you everyone for your attention. Does anyone have any questions?
Please introduce yourself first.
ID 25 counts. My question was you use CNN for training the model. As far as I know, the CNN model is used for image data processing, and this is a voice data. So how do you convert this voice data to metrics and then create CNN?
We have extracted feature from voice data. We first used MFCC, but we saw that for command detection FCC is not doing very well. And we have used Park spectrogram, and we saw that using Park spectrogram, the model was working pretty well. And in place of image, we can actually use some extracted feature from some other type of signal, in case of voice signal. In this case, it is voice signal, so it worked very well.
Anyone else? Okay. There are no questions.
Thank you.
This is our project for EEE 312 DSP Lab. The name of our project is Voice Control Based Wheelchair Control. Now we are going to demonstrate our project.
Mami. পিছনে থামো ডানে থামো পেছনে পেছনে থামো সামনে